Thank you for being here. And I am going to be joined by 4 of my colleagues. They have traveled from Beijing, Israel, Germany, and Boston, and of course, Redmond. And we also have a CTO from daenet who's going to be joining us, presenting a demo. So I have 4 demos planned. Today, AI is helping and enabling the transformation and making the businesses to rethink their entire processes. And what I'll be talking about is about the cognitive services and a little bit about bots and how we are empowering, scaling, and building scalable solutions for enterprises, such as you saw a little bit of Progressive Insurance in that video, and Unilever, and so on and so forth. Before I begin, I want to step back 44 years. We just celebrated about 44 years of Microsoft. We started with Altair 8800, a basic interpreter, with just one vision in mind, to put a computer in every desktop. Along the way, Bill Gates kind of helped establish what is known as Microsoft Research in 1991. The 3 areas where he focused were vision, speech, and language. One of the biggest reasons is because he dreamt about computers with the ability to see, understand, interpret for the products that we were building at the time on Windows desktop and Office on desktop and so on and so forth. And since then, we have tested all of this, and then we are rolling this out as finished products and providing this as APIs and cognitive services. All these APIs are tested in various areas of Microsoft. So very quickly, let me switch here and then show 1, 2, 3. How many of you seen this intelligent kiosk? If you have not, please visit us at the AI booth. We are way back in the expo thing we are hiding. There is a big BMW car. If you see that, we are somewhere there. We have some great demos in here. This, I'm going to spend 30 seconds, and my colleagues are going to come and do a deep dive here. This has about 40 demos. It includes all of the cognitive APIs. And I'm going to show very, very quickly what you can do. You can pick up something like a Vision API Explorer. And then you can get a picture, not my picture, somebody better, and do something like this, right? Ability to understand a celebrity in the picture, understand the metadata, and then all kinds of information. And then you can go into the faces, understand the faces. You can look at objects. You can do logo detection, right? That's kind of an important thing. So this is one huge capability. The other thing you can do is, if you go back to the demo gallery, you can also do things like receipts understanding. So you can go look at a receipt I have in my pictures. I have, how many of you run into this? When you scan a receipt, you have it upside down. So you try to upload to your expense tool, and then you're trying to tilt and understand. What this does is enable to understand the receipts using unsupervised learning. We roll this as what is known as forms understanding as a part of the OCR API. This is available. And many, many more things, right? So if you go, and then you can do things like video understanding. We're going to go showcase all of this today. And you can also look at some of these interesting pictures, like how many of you are Boston Red Sox fan here? All right. So 1912 champions. So this is kind of interesting picture, group of players. So you can see all kinds of interesting faces in there, and then you can understand. Some of them are not able to recognize. So things like this. So switching back, we'll be covering 4 parts: an overview of cognitive services, the first part. We are going to have 3 deep dives. Inside speech containers, that's the first part. Inside vision, we are going to talk about vision, custom vision services, video indexer. And finally, we'll talk about Cosmic Spark. So you really want to stay to the last one, because we are going to take Hendrick Motorsports NASCAR data, and then we are going to use CosmosDB, and then we are going to showcase with the power of cognitive services the information that you can find. So shall we get started? That's it? All right. Three-part objectives, right? First one, want to showcase what we have announced and what's new. Second part is about enabling cognitive services at enterprise scale. We will be using a lot of our demos to showcase the scenarios. And the last part is about get you coding. Speaking of coding, everything you're going to see here will be posted here. All the updates are available here. If you have to take a picture of one slide, that'll be this slide, mainly because we don't only serve IPA at Build. We also serve APIs. So if you come to our booth, you don't expect IPAs, but you can expect APIs. So with that, we are seeing tremendous momentum, right? So the amount of growth we are seeing is unbelievable. There are about 1.3 million developers who have tried or discovered cognitive services, 60,000 customer deployments in cognitive services. And the bots, we are seeing about 3,000 bots being created weekly. And as I go through this, I'll go through the details of this. The biggest reason we are seeing this is because of two key investments. One is our investment principles on productive, enterprise grade, and trusted. Last year, we spent a lot of time making these APIs available in about 25 regions. There are about 17 GA services. We announced a unified key to improve the developer productivity, and got about 66 plus certifications to be HIPAA certified, PCI, and so on and so forth. And we will be bringing in VNet capability very, very shortly soon. The second portion is also because of our approach. Being responsible, that's super key for us. There are sessions at Build on responsible AI, and also for AI for good. Cognitive services provide the most comprehensive capability. There are 20 services available, and 17 of them are GA. Today, we will be doing a deep dive on speech and vision. We'll also touch upon what is known as anomaly detector. That's a new service that we announced last month. Before I begin, there's one big area that is a huge competitive differentiation and provides a lot of capability. Bing search. We bring the entire corpus of world's data and then provide this as an API. So for your mobile and desktop scenarios, you can go from spelling suggestions to all the way to related searches with a single call of an API. And we are seeing this in our customers. Airbnb is maintaining great listings with the power of Bing search APIs. Grammarly, to make sure the students are not cheating in the tests, they use plagiarism checker with the power of Bing APIs. How many of you use WhatsApp? Few, okay. Millions of images are searched in WhatsApp through the power of Bing APIs. What did we announce? We announced about 10 capabilities at Build, and all of them, and one new category called decision. And we will be going through most of them at this talk. The one big area I want to emphasize is personalization. How many of you have used reinforcement learning for personalization? Few of you. It's extremely hard to bring personalization to your site. Netflix is a great example, right, of I watched this movie, how you personalize your content for yourself to watching the video. We saw tremendous lift in Xbox, the use of personalization. There is a great session by John Langford and Ed Jezerski tomorrow on Personalizer. Please attend them to get the details of Personalizer. We brought this as an API. All right, so I talked about what's new in cognitive services. Let me go to the second part, inside speech containers. At Build, we announced 4 new containers. And I don't know how many of you saw Satya's demo on the speech diarization. Pretty amazing demo where you can understand the speaker's diarization as well as your own industry jargon, right? So those capabilities, we are bringing them as containers very soon. We have been shipping containers, cognitive services APIs as containers, since December. At Build, we are announcing 4 new containers for anomaly detector, forms recognizer, speech to text, and text to speech, bringing the total to about 10 new containers. We'll show a demo of speech containers very, very soon. Here is a quick workflow of how the containerized process that we are building internally, right? We build the models. Our developers and machine learning experts build models in different frameworks, languages, and so on and so forth. Once they get checked in, we build them. This is the MLOps pipeline we use internally. We provide REST APIs and Swagger, and we deploy them as containers. This is the same container that we are shipping externally that we are also using internally. For example, our own services, when they use APIs, they use the containers. So this is the same pipeline that's being used, and they are monitored and analyzed and so on and so forth. Few examples of how customers are using containers, and the containers provide all these capabilities, the principles. Few examples. Kroger, Carnival Cruise, as well as SAP are currently using containers. In terms of Carnival Cruise, they are essentially a data center in the water. So they have very little connectivity, and then they want to understand lost baggages, sentiment of customers, and so on and so forth. In terms of Kroger, they want to map their entire customer journey from the time somebody comes into the shop to buy something, and they use Cognitive Services containers for this. SAP, today at their Sapphire conference, announced the integration of Azure Cognitive Services with their digital platform. So let me play a video that you can see some of the use cases of these things.
Our vision was to bring artificial intelligence to the places where people never even imagined that they would be able to have it before. We've got this great ruggedized 1-ton Suburban. We can take this car in a disconnected environment. There's a lot of different data collection devices that are within the vehicle. An in-car camera, 360 by 240 degree spherical camera. We're able to deploy drones from the vehicle. But when you really talk about power, the back is a little black case with the rugged Azure Stack and AI that we're able to bring to the edge. The data is amazing, but it's the AI and the cognitive services that turn it into something that we can really use in the real world. We create our own data processing in any environment that this car can get us into. In disaster relief, we have the ability to take in and start analyzing the infrastructure, bridges, roads, and we can find the most effective routes to be able to get aid into people. We can help figure out routes to get the people out of harm's way. From an enterprise standpoint, increasing inefficiencies will save companies millions and millions of dollars. Imagine power lines. We can send a single guy in a drone and a vehicle like this. He's taking imagery of the power lines. We can run the analytics based upon the models that are already built, and now we see that this part can fail or everything's working fine. Being able to take the power of Azure Stack and AI to the edge, to those people that are disconnected all over the world, and bring them the ability to do things that we've never even been able to dream of before, and now we can do that.
So I want to go deeper into speech. We announced 2 new capabilities: the conversation transcription capability, along with the speech SDK, provides a great speech diarization as well as industry-focused jargon. Neural text-to-speech that we went GA. Speaking of neural text-to-speech, we are very, very close to achieving human-like parity and far better than any other cloud vendors over there. And one of the interesting ways to showcase the neural text-to-speech is playing something like this. So I have a bunch of voices. Some of them are synthesized and some of them are recorded, human voice. So let me play the next one.
You can't know how long Tara would have been mad because that was taken away from her. You can't know how long Tara would have been mad because that was taken away from her.
Which is recorded, which is human voice? Anybody? Yeah? Second one is a human voice. Okay. Not bad. Okay, let's go one more.
Nostalgia could still be evoked after only 20 years, and many remembered when. Nostalgia could still be evoked after only 20 years, and many remembered when.
Yeah, why don't you try again? Yeah, second one is recorded. Human voice. So you get the idea, right? I think so. So let me invite Archer to talk about this. Before he comes in, we have some great scenarios in the speech. And in this afternoon, we are going to be covering what is known as what is new in speech. So if you're interested, please attend that session. There are about 5 new scenarios that we are enabling with speech. Intelligent transcription, call center transcription, conversational voice agents, connected car. If you're really interested, come to our booth, take a look at this modern voice generation. I'm going to invite Archer here to talk about mainly on the speech architecture as well as on the conversational voice agent. With that, Archer, take it away.
Hi, good morning. I'm Archer, the program manager from Microsoft Speech and Language team from Beijing. So may I ask, how many of you have been using Microsoft Speech Services? Could you raise your hand? OK, great. So because we have a lot of features this year, and Speech Container is definitely one of them. So I'll give you some details about Speech Containers and how we're going to deploy in your local host, and how Speech Container can benefit the enterprise customers like you to gain the horsepower in your speech application. OK, so inside the Speech Container, we have 2 standard container images, speech-to-text and text-to-speech. And you could connect the speech services simply using the client Speech SDK or a RESTful API, which from the developer perspective is identically the same as the cloud services. And of course, all the speech AI components are packed up, including the neural network models, the settings, the decoders, and along with a series of pre-processing and post-processing technologies. And your data, like the audio files, the transcription results, are all stored in your local host. The connection to Azure is only for building purposes. OK, so talking about the speech-to-text container is identical as the cloud services, which means you can transcribe continuous speech to text file in the real time in the streaming mode. Of course, you can transcribe, do batch transcription from audio recordings. We support 14 locales, covering Chinese Mandarin, American English, British English, German, Italian, Korean, and there's more to come. And the speech-to-text container supports voice activity detection, the intermediate results, the end-of-speech detection, and automatic text formatting, and the punctuation and the prophetic maskings. All the speech-to-text features you need. And for the text-to-speech, which means you can convert your text to the natural human-sounding speech, we support 40 locales and the 37 voices. You have different genders and personas to choose. And we support the plain text input, or you could use the speech synthesis markup language, aka SSML. So with the 2 kernel speech technologies in container, there are many scenarios that be benefited. For example, what is in my mind is voice agent. We have a lot of customers in the list, which is coming from the insurance or the telecom companies who's using the speech container in their voice agent systems because they require a high data privacy and on-premises deployments. So the typical structure could be like this. You deploy a bunch of STT containers and the TTS containers in your local machine, and you could use a container orchestrator like Kubernetes or Docker Swarm. So by hooking up with the CRM pipeline you desire for your business, you could get the real-time voice generation, voice activities with your users and customers. And of course, you could use other container services like Louis for the better language understanding performance. OK, so how to build this? It could be as easy as 4 steps to enable the speech container. First, you have to apply the container registry because it's in the previous stage. and create the speech subscriptions in Azure. Then download the speech containers images to your local host and run it. Use the standard Docker command and Speech SDK. Then you're all set. The usage could be submitted to the Azure for the billing purposes. And we have some guidance for your machine setups. And don't forget that your machine have to support the advanced vector extensions, the latest instruction sets. OK, then we'd like to give you a live demo on how to set up the speech container in 2 minutes. I'll give you Yusuf.
Hello, everyone. So I'm going to switch to my machine. So to start the container, you usually just log into the Azure Container Repository. I already did that. Then we need to pull down the image. So I'm going to pull down the Microsoft Cognitive Services Speech to Text. This is the latest tag, which is the ENUS model by default. Like Archer said, we have multiple languages and multiple cultures available that you can download. So by doing so, I pull down the image. Next, I do the run. So the image is already downloaded, so I don't need to do that. So for the run, we just specify the port, optionally CPUs and memory, and just the image. And for cognitive services, there are a couple of standard parameters, which is the EULA, accepting the EULA, the billing URL, and the API key associated with it. Now the container is running locally on the machine. Now we need to set up a Python script to actually test this Docker container. So I've gotten a sample that uses the Speech SDK as well as just a normal speech file. So the only change is we remove this line, which specifies the region and the subscription, because this is not going to talk to the container, the cloud service. It's going to talk to our container. We specify a subscription, which is just no key is required, because when you set up the container, you actually give it the key in there. So any string here would be fine. And we specify an endpoint, which is a WebSocket, to the localhost 5000, and the path. To get the actual path, we need to look into the container. So we would go to localhost 5000, and you see the blue screen of happiness. And now the service API description would tell you just the different endpoints that we have there. So once we copy this over and do this, then we're ready to go. So here is the demo, and this is the video, the audio that I'm using.
Skills and abilities. Batman has no inherent superpowers. He relies on his own scientific knowledge, detective skills, and athletic prowess.
And as you can see, intermediate steps are shown, and finally the whole audio is available. And that's pretty much it. Back to you, Archer.
Thank you. Thank you, Yusuf. And it's definitely a great demo. So I want to emphasize again that when you use the speech container services through the SDK, don't forget to replace the region with your local endpoints using WebSocket. OK? So just get started and find more at aka.ms speech container. Thank you. That's it. I'll get back to Anand.
Thank you. So that was Archer, who came from Beijing. He's a software engineer, program manager at Beijing for the speech team, and Yusuf who's a software engineer based in Redmond. Thank you, both of you. So everything that we showed will be available in this URL as well as the URL I showed in the past. So let me move on to the next one. Inside vision. So I showed some of the interesting demos of facial recognition and so on and so forth earlier today. And what Yusuf just showed with the speech container, you can do exact same thing for images with image containers, and we are bringing more and more of those capabilities. At Build, we announced 2 new APIs. One is ink recognizer, and another is form recognizer. Custom Vision, we just announced the GA of Custom Vision capability. All of these things are enabling amazing scenarios, enterprise scenarios. How many of you attended Laila's session on Inside Vision yesterday? Anybody? Okay, so unfortunately you did not. So I'm going to, there's one person. So I'm going to touch upon the areas that she covered on the 5 scenarios. Number 1 is industrial processing. So how do you understand there is a security threat? Somebody is wearing a helmet or not a helmet in industry scenario. Real estate and facilities having a responsible facial understanding. Finance, understanding. So at Microsoft, we have what is known as MS expense. So when we go on a trips, when we scan the receipts, so we expense all of those things. How do you automate the entire process using robotic process automation? We use that within Microsoft using computer vision, OCR capabilities, and CosmosDB, and so on and so forth. How do you do that? 4th one is media and entertainment. We are going to go deeper into media and entertainment scenarios at this talk. And then the last one is workplace accessibility. How do you make sure every person, either you are impaired or disabled or whatever the reason you are, you have the same kind of the access the rest of us have. So when you look at the amount of data that is growing, the one area that is growing so much because of all the digitization capability is video content. And our partners, OpenText, as well as MediaValet, they are providing digital asset management products. So the only way you can get insights into all of this content is using AI. And we have a great product, what is known as Video Indexer. Anybody in the audience have used Video Indexer? Okay, few. So we're going to go deeper into Video Indexer today. Video Indexer is built on top of Azure, Azure Media Services, Cognitive Services, Azure Search. It parses the video and audio files using ML algorithms. It's available as a service as well as the platform. You can get started free in minutes. And when you ingest a video file, it streams them into 2 areas. There is an audio portion as well as a video, and applies all types of cognitive APIs and gets a lot more intelligence into this and enables some great features as a part of this. The best way to show this in depth is using a demo. And I'm going to invite Elan. Elan has come all the way from ILDC, Israel Development Center, to present this. Thank you, Elan. After he finishes, he'll hand off to Andreas, who is the CTO of daenet, who will come and present the next portion of the demo. Take it away. I don't know, you don't need this.
Hi, everyone. My name is Elan. I'm a software engineer for Video Indexer. And today I'm going to briefly show you what Video Indexer is and how you can use it as well. So first, what is Video Indexer and why is it useful? Manually tagging all of your videos, all your library, is lengthy and expensive and can also be inaccurate. Video Indexer automatically extracts metadata, or insights as we like to call them, using both the video channel, audio channel, and combination of both. Video Indexer, by the way, award-winning product, worth mentioning. Well, you probably ask yourself, what are those insights that I'm talking about? Luckily, I can use our very intuitive UI to show you just that. So if we'll take a look at the right pane, you can see that we have a bunch of insights there. We are able to identify faces that appear in the video. We can show you exactly all the faces that appear in the video and where they appear as well. Moreover, if the face belongs to a celebrity, we're able to identify the celebrity from a library of over 1 million celebrities. For instance, let's take a look at John F. Kennedy that we identified in the video. Skip to the part, and indeed, John F. Kennedy appears. Next, we are able to identify the topics that are referenced in the video. We use multimodality topic inference model to do that. And we're able to detect that nuclear weapons were mentioned, international relations, and so on. Once again, you can see where exactly in the video this topic is related to. We're also able to identify objects that appear in the video. And again, as all of our insights, you can see exactly where they appear. And we are able to identify a military uniform, and indeed, it is there. We are also able to extract brands from spoken words in OCR that also appear in the video. And once again, we show you exactly where they appear. Let's take Microsoft as an example. You can see here that Microsoft indeed is mentioned. One very unique feature that we have is the ability to identify the emotions that were in the video. We're able to differentiate between 5 emotions: fear, anger, joy, sadness, and neutral. Recently, we introduced a new feature called scene detection, we are able to break the video into its scenes. Each scene consists of many shots. If we'll add over to the timeline, we can see that we've also transcribed the old video. And not only that, you can also translate the transcription as well as the whole experience to more than 50 languages. Now you probably ask yourself, how can I use Video Indexer? Well, you can use the UI. This is one option. You can also embed either the player pane or the insights pane to your app. You're also able to use our very intuitive and well-documented API, all the operations and actions that you are able to do using the UI. You can also use the API service to do that. And lastly, you are able to use logic apps. In fact, it's so easy to integrate with logic apps that I'll show you. I will show you that right now. Logic apps, for those of you who don't know, is a cloud service that enables you to automate workflows. So let's say that our task in hand is that whenever a new blob is being uploaded to a specific container, we want to index this blob using Video Indexer. So I have a previously set up logic app with the non-Video Indexer related steps. And now I'm going to add the Video Indexer related steps. So first, we need to generate an access token to access our account. And we'll pick up the correct location, the right account. Yeah, we don't want to allow edit because we're going to upload a new video. And all that is left to do is upload video and index, which is a one-step process. Once again, we'll choose the location, choose the correct account, use the access token that we generated in the previous step, use the video name, we'll pick it to be the blob name. Video URL will be the web URL with SAS that was generated in one of the previous steps, and that's it. Now we can save this logic app. We will upload a new blob. Once it will be uploaded, great, let's run the trigger manually for the sake of the demo. And with a little bit of luck, once I refresh, no luck yet. Yep, no. We can see that the video is indeed being indexed. Well, that's it for me. Allow me to invite Andreas to show you how we used Cognitive Services and Video Indexer for even more capabilities. Thank you.
Thanks, Elan. So Elan gave you a great overview about what Video Indexer can do. So I'm from a partner company called daenet. My role is CTO for mixed reality and AI. And customers always ask us, oh, that's great, but they want more. So we're looking at how can we even do a little bit more, enrich what we do with Video Indexer for specific scenarios. So in this case, brand insights. Our customers tell us, hey, we want to discover those brands in those videos, but we also want to discover the logos, the visual logos, and we want to maybe onboard new customers of ours where there's nothing around there. So what we looked at, combining and adding some services. We're using computer vision API and custom vision additionally. Why is it relevant, right? I mean, we want to maybe find a spot in a video that's a good visual representation of the specific brand, or we want to find an area in a video where an advertising customer might find their brand also in the video context, and then, boom, put that video, the advertisement right in. So what I'm showing you here is not a sophisticated cloud architecture. We really simplified the scenario for developers. It's basically a UWP app based on a sample. We strip down all the stuff we don't need. We use Video Indexer API to get the basic insights into the video, which also provides us keyframes. Keyframes are already good locations in the video to analyze because they're not blurry, for example. And then we extract keyframes in a high quality from the raw video material with the UWP WinRT API, send it through the brand detection of computer vision with the C# SDK and the specialized brand detection with custom vision that we built. Now, let's have a quick look of how that looks like. So this is a video that we've just seen with a car, right? And what did Video Indexer find? It found the Microsoft brand, and it found it in 2 spots in the video, right? So here, for example, and here. Now, the question is, can we do something that can detect more? So for that purpose, again, computer vision SDK, and we also trained a custom model of seeing the Microsoft brand in the wild based off regular pictures we took. So we found like on wardrobe, on cars, on hats, or to really make sure we don't miss anything. Now let's run that little demo app we have here. And it will go through that video keyframe after keyframe after it gets the video indexer results and display the best thing it found. Now, after a few seconds, right, we're right now looking at second 7, oh, now second 13, and we found something, right? In that, on the right side, you see the currently best picture we found. The red squares are from computer vision, and the blue ones are from custom vision. Looking back at Video Indexer, we found that at the timestamp it was around 13. Wow, that's a nice shot of the car and the brand moving right through the image, right? Now, let's look at the code. How is that done? Again, we're running the sample. The first thing we do is we call Video Indexer. And we need to log in, right? So we get basically type of session key. After logging in into our account, which is all REST calls, by the way, we're calling, hey, give us all the indexer results, which is a really pretty big, let me display it quickly, a big JSON that has all the insights as JSON. Now, what do we do? What do we do with this? Now, we could put it into an object, and then we actually extract the processing state with a deserialized function of JSON convert, part of the JSON tools for Newtonsoft. Another thing we also do, we want to get to those keyframes really quick. For that purpose, we actually use JSON path, similar to what you know from XML and XPath, but for JSON, and get a list of all those keyframes, and then we start looping through them. Okay. The breakpoint will hit the next time. It's the conditional breakpoint when we found that nice image. Right? And this is a call through to the custom vision prediction SDK. We don't need to do much. We can really send the streaming raw data, which is in-memory stream in this case, to the service. Here, we get the account, the specific service address from the custom vision portal, and we get results back. In the result set, you see that one prediction was made. We found the Microsoft logo with, they call it probability, but a confidence of about 92%. That's one of the insights, and if we continue, we do the same thing with the computer vision API. And the brand was found 2 times here. As you've seen in the markings earlier, one time was the actual text Microsoft, the other one was a brand logo with a specific confidence. Now, this now runs through. You have seen that already. So I will switch back to the slides. And the takeaway is that it's pretty simple to develop those scenarios to extend the functionality of Video Indexer, right? I encourage you to get started. To build this out probably costs, well, maybe around 1 afternoon for a good developer. And you can give something to customers they probably didn't think they could get. Anand?
Thank you. Okay. So I want to thank both Ilan and Anders. Ilan came from, as I mentioned, from Israel, our team, and Anders from Germany to come present this demo. So what we showcase is a bunch of digital asset management scenarios that daenet and his company like OpenText and then MediaValet that they use to index large corpus of video data and then creating scenarios for brand detection. Many cases like this. So the last part, we always save the best for the last. Cosmic Spark. So one big announcement that we are making today is the integration of Spark into Cosmos and also providing a native notebook in CosmosDB. So how many of you have used CosmosDB here? Great. It's one of the fastest, if not the fastest, growing workload NoSQL database at Microsoft. If you think about the enterprise requirements, right? Today, the applications have to be available all the time and have to be served with low latency, have to be available to the users in the region they are, and have to have a great SLAs and fine-grained elasticity and so on and so forth. These are all the common challenges enterprises are seeing. To tackle this challenge, you really need a completely different way of managing data, and that's where CosmosDB comes into picture. CosmosDB is Microsoft's globally distributed multi-model databases, provides 5 SLA guarantees, and has support for Cassandra, Mongo, various APIs, and now we are announcing the Spark API support, and provides the ability to scale both the storage and throughput, and in the matter of minutes, you can provision this database across the world. So we are available in all Azure regions with CosmosDB. And recently we announced the connector to Spark DB. Before that, there's a whole bunch of enterprises that have taken a dependency on the power of CosmosDB. And even at Microsoft, we use CosmosDB across all our enterprise solutions. Last year, we announced this native connector to Apache Spark, and also provided ways to architect for the Lambda architecture. Today, we are announcing this integration with Spark APIs. The best way to showcase this is using a demo. So what we have done with the demo is, I'm going to invite Mark Hamilton here to showcase the power of CosmosDB. What we have done in this demo is we have taken the data from NASCAR. Hendrick Motorsports is one of our largest partners, and they have been pioneers and have been winning a lot of races mainly because of their use of data, use of AI. And what Mark is going to showcase is the depth of the new features of CosmosDB, and then he's going to showcase all the interesting things. Take it away, Mark.
Thank you very much, Nan. Switching on over. Hi, everyone. I'm Mark Hamilton, and I'm a software engineer on Microsoft's Applied AI team. And today, I want to show you how we can use our open source Apache Spark machine learning library called Microsoft Machine Learning for Apache Spark, and CosmosDB's new announcement of a native Spark platform to create a real-time racing analytics system for Hendrick Motorsports. Today, we'll be taking a look at the AAA 500 race on the Texas Motor Speedway. This is about a 3.5-hour race with 500 laps. And every single second of this race, we have about 1,000 rows of data coming from the over 50 cars out there. So what Hendrick really wants to do is to be able to take this large streaming data source and be able to understand it, chop through it, and figure out ways that it can improve not only its racing performance, but also its safety and its efficiency. So we can start off right here in the Azure CosmosDB Data Explorer. And what I'm showing right here is a Jupyter notebook. This is basically like a distributed 5.9 SLA multi-model PowerPoint that's Turing complete. So we can actually explore it and explore the data and also run code against our CosmosDB query database right here. So the first step is to read in the telemetry from CosmosDB. And as Anand mentioned, that this CosmosDB cluster is kind of enriched with Spark right here. So the actual compute nodes are right next to the data, so it's about as low a latency you can get. And furthermore, this notebook is actually embedded directly within the CosmosDB Data Explorer. So we can come over here and take a look at some of this data that we have. And we have a lot of fields to play with today. We have the car number, the latitude, the longitude, all the telemetry coming off the engine, like the RPM, the throttle, the brake. And all of this is at kind of a sub-second time scale for every single car. So we have a lot to explore here. So really quickly, we can use a Spark query to just visualize the first few seconds of the race to kind of see what it is we're dealing with. So we have this oval track, and all these cars are racing around, and we've highlighted a few from the Hendrick team and the winner, Kevin Hart. And so what's nice about this kind of integration between Spark and CosmosDB is that it's incredibly fast because it's only reading the data that it needs to. If we come up and look at this query, we'll see that we're doing a Spark filter up here. And what Spark is actually doing is taking this query and pushing it down to CosmosDB, so it only reads the data that it needs, and it's exponentially faster as a result. So now that we kind of have a rough understanding of what our data set contains, we can take a look at a more complicated query that can let us understand a little bit about the dynamics of the track itself. So here, I've taken some of the braking and the throttling data, and I've overlaid it on the actual track, and we can really quickly visually identify areas where everyone's slowing down in order to get around a hairpin turn, and areas where people are really slamming on the throttle in order to extract seconds. Not only can we chop up this data by the track, we can also look at how individuals' drivers perform in only a matter of seconds. So here, I'll take that data frame that we loaded in our first cell. I'll join it with a data frame of driver information. So this is like the names and where they finished in the race. And for every single driver, I'll aggregate their average time spent braking and their average time spent on the throttle, and I'll display it in an interactive chart. So right here, we can take a look at this, and the winners are over here on the left, and the losers are over here on the right. And as you can see, this nice downward trend, which really shows that the more experienced racers tend to spend a lot of time on the throttle to really extract the most amount of speed as possible. And what's nice is that this whole notebook is collaborative, so others can view it, and we can kind of explore this in real time and hone in on specific things and adaptively explore our data right here. So this is great and all. You know, we've shown that CosmosDB can do a lot of queries and aggregations. But what's nice about Spark is that this is not just a query thing. It's not just a database. This is a full distributed computing framework. It does MapReduce. It does more complicated communications. And it even has connections with MPI. So you can really have any kind of parallel computation embedded inside your CosmosDB cluster. One of the things that we're excited to talk about is the Azure Cognitive Services on Spark. This is an open source integration between all the cognitive services in the Spark ML distributed machine learning library. What this lets you do is take the cognitive services and all of this cloud intelligence and embed it directly within your Spark workflows so that it's easier than ever to kind of apply the cognitive services at scales in the terabytes and the petabytes. And you can learn a lot more about this at our website, aka.ms/Spark. So here, I'll show an example where in a few lines, I can create an anomaly detection algorithm. I can group by the car number and apply this anomaly detection to each car's RPM values. And in only a few seconds, this will actually churn through our entire distributed database because we're leveraging the full parallelism of the Spark cluster to kind of DDoS these services. And right now, it's using the Cloud API, but as we mentioned before, we have containers. So other talks that we've given before actually embed these containers directly on the Spark cluster, so you can keep your eyes peeled for that. And in order for our demo, we'll take a look at a specific car, namely number 32. And we can go ahead and plot this. And so what you'll see here is we got a lot, but we'll kind of unpack it slowly. We have, in the blue line, is kind of the measured RPM coming off of car number 32. The gray confidence intervals are coming out of our anomaly detector, and everything that's outside of those gray confidence intervals are marked in red as anomalies. And so without knowing anything about the data that we've plugged it in, it's already detected a few key anomalies in a bunch of different places. And so if we can kind of zoom in on one of these, I've also labeled the NASCAR's like warning flags. And so if any of you have seen racing, you'll know that when like a car crash happens or there's debris on the track, NASCAR will start a warning flag, which will effectively say, hey, everyone should slow down, they should follow a pacer car. And the anomaly detection algorithm immediately picks up that this is a deviation from the standard seasonality of laps at high speed and fires off a few detections here. What I want to bring your attention to is this particular anomaly here at the end. So as you can see, we have a warning flag, and our RPM goes to 0 as opposed to something before that was still high, but not that much. And even after the warning flag is lifted, this green line right here, we're still at 0. So you might be wondering, what's going on here? And luckily, we have kind of the video footage from ESPN or something, so we can go ahead and take a look at what's going on here. So this is
line he chooses. Yeah. He chooses the inside line again. The 12 car, Blaney has some experience.
Just taps 33 there. Boom, immediately peels out. So this is why our RPM is going to 0, because it's smashing into the sidewall as we speak. And so I kind of feel that technical demos in NASCAR is very similar in that you go, like a lot of people say they go for looking at the sport and looking at the race, but really you're just going to see the crashes, right? So hopefully that doesn't happen to us. So in addition to having all of this kind of live telemetry coming off the cars at sub-second intervals, Henrik also has a live audio feed hooked up to every single one of the drivers, and this is pulling gigabytes of data in every single race. And ordinarily, that's a real pain in order to go through and index and figure out, and they have to kind of do it manually with these large audio files, and it makes it difficult if you want to pull up conversations you've had with your drivers or understand what kind of insights they're saying. And so what we can also do is use the cognitive services on Spark, this time speech to text, in order to take this large data frame of speech that's tied to every single timestamp and pass it through speech to text to actually extract this transcript in a searchable form that we can then store in the CosmosDB cluster and query with any of the different models like the Gremlin API or the Mongo API. And so we'll just take a look at the first individual result from this query and play it.
I'm ready to go here if you are. Yeah, the 11, he was right on the bottom.
Yeah, so as you can tell, this speech is really hard to understand even as a human being. You know, it sounds like it's being composed through like 30 different walkie-talkies. And, but the speech-to-text service is trained with like a neural speech model, so it's even without any fine-tuning, through custom speech, we can immediately pull out this transcript. We didn't train it with any jargon or anything like that. We can just use it right out of the box for a lot of different things. And so, you know, all of this stuff is great, but what Henrik really needs is something that's not just for after the race, after all the data comes in. They want something that's real time, that will actually do this in single millisecond latency and keep up with a huge amount of data that's coming in live. And so this is where Spark can really help us out, in that when you code using the Spark API, you can code in batch and then immediately switch your job to streaming. And we've also added serving, so you can turn it into a distributed web service, but that's another talk. So in this case, we'll take our data frame, and instead of saying spark.read, we just change one line, spark.read stream, and we can now pull from CosmosDB in a streaming fashion. We can do the exact same operations, you know, all the kind of Spark SQL operations, Python operations, machine learning operations we want. We can even join it with other data frames that can be streaming as well. So in this case, we'll join it with speech. And finally, we'll pass it through the models that we created, namely the anomaly detector, the speech-to-text model to download the audio files, and we'll write it out to a new CosmosDB table. The effective result of this is that we're reading in unenriched data, and we're passing it through a bunch of intelligent services in order to make it more usable for our end users, namely Henrik. And so we can take a look at the query status, and we'll see that it's actively processing new data. It's kind of pulling in that large chunk. And as new data is added, the new database will be updated in real time. So we can take a kind of a step back and look at the full end-to-end workflow now. We've started with telemetry from over 50 NASCAR cars that are coming in thousands of rows per second. We've put them in like the world's largest geographically distributed NoSQL database with 5 nines and single millisecond latencies. We've passed these through Spark SQL, so you can do all sorts of different kinds of computations. You can put in your favorite Python hacks. You can use code in R and Scala and the entire ecosystem. You can also directly embed cognitive services into your pipeline to add cloud intelligence. And I didn't have time to mention this, but there's also a full distributed machine learning library. So if you want to train your own custom models on your largest of data sets, you can do that using Spark ML and also using TensorFlow on Spark. And finally, we can write this back out to CosmosDB in a streaming fashion to give a new, more enriched, intelligent view of the data that Henrik can build Power BI applications on, or build alerting pipelines, or build web services on. And the best part is all of this stuff is open source. Our cognitive service integration is open source. Our distributed machine learning library is open source, and you can check it out online. Thank you very much for your attention, and I hope you have a great rest of the Build conference. I'll pass it back to Anand.
Stay. So, Mark, how long did it take you to build the demo? Stay there. Stay in the architecture.
Yeah. So this demo came on the plate last week. So all this kind of came together in the past like 3 or 4 days. So it's really fairly easy to get started. And I never used the CosmosDB notebook interface before. So it's really easy to kind of explore this data interactively. Yeah.
So this is kind of the AI-oriented architecture that you're working with, Henrik Motorsports. Mark is from our Boston office. 23 years old. He's joining MIT this summer, so congratulations and thank you
very much, Sean. Thanks, guys.
So we showed a lot of things. Vision APIs, speech containers, speech APIs, anomaly detector as a part of this Henrik Motorsports, speech to text to speech, so on and so forth. So please come back and visit us. We have a large booth way back, so it's hard to find. So that's the only thing. We need some kind of AI to get you guys there. Way back, if you look at a BMW car, search for them. We serve IPAs and APIs, so remember that when you come meet with us. Whole bunch of sessions today. What's new in speech services is this afternoon, if you want to go understand. Forms recognition, personalizer, and all kinds of interesting sessions. So I want to end with a thank you and a video, and I have time for questions. So let me play the video, and then we'll stay back and then answer as much questions you want. So thank you for being here. So let's roll the video.
Today, right now, you have more power at your fingertips than entire generations that came before you. Think about that. That's what technology really is. It's possibility, it's adaptability, it's capability. But in the end, it's only a tool. What's a hammer without a person who swings it? It's not about what technology can do, it's about what you can do with it. You're the voice, and it's the microphone. When you're the artist, it's the paintbrush. We are living in the future we always dreamed of. We have mixed reality that changes how we see the world, and AI empowering us to change the world we see. You have more power at your fingertips than entire generations that came before you. So here's the question: what will you do with it?
Thank you, everyone. You have been a great audience. We will stay back here. I'll ask all my co-presenters to be here. So come in the front, ask questions. If not, I'll see you all at the booth this afternoon. Come back for IPAs and APIs. Thank you.